So good morning. So today I am going to discuss about angular velocity measurements. So for measuring angular velocities we are using tachometers. What is tachometer? Tachometer is used for measuring rotational speeds that can be used to measure speed of rotating shaft, can also be used to measure flow of liquid by attaching a wheel with inclined vanes. Tachometer is a transducer. It is one of the important device for measuring angular speeds. So tachometer is an instrument which is used to measure the speed of object or a substance. It is also called as a revolution counter. This device usually describes the revolutions per minute (RPM). It is calibrated on analog scale or digital scale. The tachometers are normally using in aircrafts, two-wheelers, cars and other vehicles. Shows that the rate of rotation of engine crankshaft, and there would be a making that it shows the safe range of rotation speed. So tachometer can indicate the angular speed of a rotating vane or rotating shaft. So this is the one of the instrument you are using to measure the angular speed of a shaft or a vehicle. Now let's see what are the classifications of tachometers. Tachometers based on the data acquisition. So the tachometers are classified into two types. One is contact type or non-contact type. The second one is based on the measurement techniques, time-based techniques and frequency-based techniques. The next classification is based on the method of display, digital tachometers or analog tachometers. Now based on the working principle, electrical tachometers or mechanical tachometers. Okay, so these are the different types of classifications of tachometers. Now the most commonly used tachometers based on the signal, that is mechanical and electrical tachometers. So here there are different types of mechanical tachometers for regular applications we are using in automobile industry and other applications. So in the mechanical tachometers are again classified into different types. One is revolutionary counter, that is stopwatch, hand speed indicator, tachoscope, centrifugal tachometer, and resonance or vibrating reed tachometer. So all these are the comes under the mechanical tachometer. Now let's move on to the electrical tachometers. So electrical tachometers we are classified into different types. One is drag cup tachometer or eddy current tachometer. So in this type of arrangement we are using a aluminum cup putting as a drag type shaped in a magnetic field. So here it works on the eddy current principle. What is eddy current means? Eddy current is always opposes the magnetic field. So based on the principle this tachometer works. The second tachometer is a tachogenerator or tachometer is AC or DC tachometers. All these three comes under the electrical tachometers. The next one is contactless electrical tachometers. So here the main important contactless electrical tachometers are magnetic pickup tachometers, photoelectric tachometers, and most commonly used electric tachometers using contactless, you are using stroboscopes. So these are the very portable and contactless. For normal applications we are using contactless electrical tachometers. Okay, so these are the commonly used tachometers for measuring the angular speeds. Now let's see what is the difference between analog tachometer and digital tachometer. So as the name suggests, analog tachometers, it is a needle and a dial type of interface, and there is no provision for storing of recording. It cannot compute average deviations. Okay, now let's see what is digital tachometers. Digital tachometers are optical encoders which can be determine the angular velocity of a rotating shaft or a motor. So the values are displaying using LCD or LED. Okay, so the tachometer, the speed of rotation RPM always displays in LED or LCD. But here it is a continuous scale. The pointer or dial scale you are using the analog tachometers. Now let's see contact type tachometers. A tachometer that has a contact with the rotating shaft. In contact type tachometers, the contact type tachometers are fixed to the machine or electric motor, or an optical encoder or a magnetic sensor will be attached to it. It can be measure the RPMs directly. This type of tachometers are generally fixed to the machine. Contact means it can attach to the machine. What is non-contact means? It is not at all attaching. A tachometer does not need any physical contact with the rotating shaft in the non-contact digital tachometers. So here in this type, laser optical disc attachment to the rotating shaft, and it can be read by IR beam or laser beam is directed by the tachometers. So by using this, it can measure the ranges from 1 to 99,999 RPM. The measurement angle is less than 120 degrees and it is an LCD display. So non-contact tachometers are efficient and durable. They are accurate and durable too. So it is preferred where tachometers needs to be mobile. So the best example of non-contact is stroboscopes. What is electronic tachometers? So it's purely made of electronic components used to measure the speed of an engine or any other moving object in RPM. These tachometers are lightweight, accurate under all conditions. Okay. So the electronic tachometers are always advantageous than mechanical tachometers. So the examples are drag cup tachometers, AC or DC tachometers. Mechanical tachometers. These tachometers are simply cable driven meters that use magnetic assembly with attached needles or other indicators. The cable is driven from the camshaft or a distributor shaft, and it is other end turns to the central assembly in the gauge. So greater magnetic pull can be seen if the cable turns faster and the dial will show the higher readings. Time measurement. A tachometer that calculates that speed by measuring the time intervals between incoming pulses is called the time-based or digital tachometers. Okay, in terms of time, it is accurate to measure low speeds. The reading time depends on the speed and increasing with decreasing the speed. Its resolutions is independent of speed of measurement. It is a continuous. Frequency measurement. A tachometer that calculates the speed by measuring the frequency of pulses is called frequency based digital tachometer. It is more accurate for high speed measurements. Its reading time is independent of speed of rotation and resolution depends on the speed of the rotation shaft. These tachometers are of high efficiency and low cost. How to choose a tachometer? So by using these parameters, we have to choose the tachometers. For different applications, we are using different parameters. So the main important parameters for any tachometer, one is accuracy, precision, is it contact or non-contact type, range, acquisition time, portable or fixed, analog or digital, and the cost of the tachometer. So depending on the application, you choose any of the parameters, and to measure the speed of rotational objects, we are using different types of tachometers. Okay, thank you.